morning everyone. So in the last class, if we see, we have started doing the numerical analysis. So like throughout this class, we have studied how to calculate the free vibration response, then force vibration response, damped, undamped. And once we are doing the force vibration, we first see if the force vibration has some specific function. For example, if it is like a linearly increasing, if it is some sort of like a triangular shape, if this has something like impulse type, how to solve those responses. We have also seen the Duhamel integral, and we have also understood what are the difficulties associated with those methods. So from there, and then now we have started doing the numerical analysis. Like we can try to write the ordinary difference. We have the ordinary differential equation, and now implementing the standard procedures, we will try to solve these ordinary differential equations for any type of the loading, and in the different time steps we are going to solve it. So this we have started in the last class. We have seen there are two types of algorithms. One is the implicit scheme, another is the explicit scheme. So implicit and explicit is like at what time step we are. If we are predicting the next time step without having any of the state information considered of that state, then this procedure is primarily known as the explicit scheme, and there we need to have like a small time steps, because otherwise, as we have just only the information of this current state, therefore chance of error can be quite high if we are taking a larger time steps. So time steps should be smaller for that. And then we have checked the implicit scheme. So in explicit scheme there are the two types of method we have studied. One is the central difference method, and another is the Euler integration scheme. And then we went for the implicit scheme, and in implicit scheme we are actually studied the constant acceleration and linear acceleration case. So did we completed the linear acceleration? Yes, we did that. Yeah, so like we told like how to set up the full thing, and we have started. Yeah, so that implicit scheme we have checked. So now today we will proceed further with the other sets of the implicit scheme, and we will also try to go for the numeric beta. We will start with the numeric beta even, and then we will proceed to the Runge-Kutta, then state variable approach, which is the very commonly used solver. Okay, so let's begin today's class. And before we start, any doubt from anyone? Yes, so we completed after, yeah. So we have done the linear acceleration and constant acceleration case. Now these two methods can be generalized using the numeric beta. Now let's go for the numeric beta method. So that you can consider as like a more generalized version of the linear acceleration and constant and the average acceleration case. So here what we are assuming, so we are just doing first the Taylor series expansion. That is like a most common thing to do. Whenever people fall into trouble, they do the Taylor series expansion. Okay, so x dot I plus 1, that will be x dot I plus del okay. So what they're doing, they're telling that this term is nothing but equal to xi plus delta t by 2 xi dot sorry, not delta t by 2, sorry. Delta t xi dot plus delta t square by 2 xi double dot plus beta times xi triple dot. So whatever the term here is just written as beta times xi triple dot. Okay. Beta times delta t cube into xi beta dot. Okay. And the bottom one is also written as xi dot plus delta t xi double dot plus gamma times delta t square into xi triple dot. Because none of the cases we will want to go for more than triple dot, because triple dot is already the jerk. After jerk, we are generally don't care with that. And also you can see that delta t to the power 4, delta t to the power 5, delta t itself is a very small quantity. So these actually become almost like a negligible quantity. So we don't need to consider those. So we can ignore that part. Or not ignore, we are like condensing that in terms of the jerk and we are taking it. So now if you think, now if you assume that acceleration is linear, now if acceleration is linear, as we have seen in the last case, the linear acceleration case, in that case what will be the jerk? No, linear, that will be jerk will be this much. Yeah, because what will happen if you think, so this is that I, this is that I plus 1, so you will have your acceleration this much and acceleration is this much, and that is increasing linearly. So jerk will be basically the slope of it. So it will take delta t times, and how much is the difference? So this, so slope will be this divided by delta t. Okay, so that will be my jerk. So now if I substitute this jerk term into these two equations, then what can I get? Then I can get xi plus 1 will be equal to xi plus delta t into xi dot plus delta t square by 2 into xi double dot plus beta times delta t cube into xi plus 1 double dot minus xi double dot divided by delta t. Make sense? So these, if I little bit simplify, what can I get? Now here you can see that delta t and that is can be cancelled out and cube becomes square. Okay, so we will left, and now if we start clubbing the terms, so we will have 1 by 2 minus beta into delta t square into xi double dot plus beta into delta 2 square into xi plus 1 double dot. Okay, will that be all right? Like I just club the terms properly. Like here we have xi double dot, here xi double dot, I just club this two, and xi plus 1 double dot, I just take it out. Okay, now if you go, this one will become delta t xi dot double dot plus gamma times delta t square into xi plus 1 double dot minus xi double dot divided by delta t. That will be cancelled out. So you will have xi dot plus delta t into 1 plus 1 minus gamma into xi double dot plus gamma into delta t into xi plus 1 double dot. Does that make sense? Can we get these two equations like this? All of you agree? Good. So if you agree with me, then what was my first equation? Or I can say minus mug double dot. All is all right. Okay. And that we are solving for which step? I or I plus 1? I plus 1. Why? Next step. How many of you agree with Amadi? Agreed. Very good. Yeah, it is true. We should solve for I plus 1. It's an implicit scheme. So implicit scheme, solve for I plus 1 step. Okay. Explicit scheme, solve for ith step. Implicit scheme, solve for I plus 1 step. These are some of the important points, like implicit, explicit, that point are quite important. That, like, suppose if you are making some solver by yourself, those things are particularly very important, that where you are solving. Are you solving in the previous step? Are you solving in that step? Or you are solving in the next step? So m now xi double dot. Okay, how to calculate xi double dot? We should not need to calculate. We will find out the value for xi double dot. So xi plus 1 double dot will be here, plus cxi dot. Cxi dot will be this one. So it will be this plus delta t into 1 minus gamma into xi double dot plus gamma into delta t into xi plus 1 double dot plus k into xi plus delta t xi dot delta t square xi plus double dot plus beta into delta t square xi plus 1 double dot, that will be minus mugi plus 1 double dot. Okay, so that is the complete form of the equation. If I substituted the calculated value of the xi double dot and xi plus 1 double dot, xi plus 1 dot and xi plus 1. If I substitute that too, we will get this one. Okay, all of you agree with that point? Nice. So then, what is known, what is unknown? Let's have a tally of that. M known, unknown. Obviously known. C known. Delta T known. Gamma. Yes, for gamma and beta, maybe you may think that whether it is known or unknown, because this parameter comes here and here. So for solving that, you have to assume some value of the beta and gamma. There are some ranges given, and based on that range, you have to assume that value for your solution. Okay, so beta and gamma are known. So beta and gamma are also known value. They are not unknown. Delta T is known, K is known, delta T is known, half is known, beta is known, delta T square known, beta known. These all the values are known. These are also known. Now if I see what left, I have xi double dot, xi plus 1 double dot. Is it known term or unknown term? Unknown term. Perfect. So I just put it here. Okay, so that is unknown. Then is it known or unknown? Xi dot. Known. Why? Why? Exactly. We have already calculated the ith step. Means previous step is already calculated. So obviously xi dot xi double dot. all will be known. Okay, so this is known, this is known, this is again unknown, known, 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 unknown. So what we can see, only parameter is xi plus 1 double dot will be equal to some value. Make sense? Can you able to solve it? Can you able to solve it? Yes, exactly. Why not? It is just a simple equation. We can easily able to solve it. So once we get that solution, then what to do? Suppose if I just mark it like 1, 2, 3, 4, 5, 6, maybe 7. So once we get the solution of xi plus 1 double dot, then we need to substitute that value in equation 4. So we can able to calculate xi plus 1, and again in equation 5 there also you can able to calculate xi. So you can see here, like this term is unknown, this is known, this is known, this is known, 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 and now it is also known. So it is completely known. We can just get the value out. Done. This term, if we see, known, 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 all known. So we can just able to calculate the values. Done. So we'll write a for loop. Inside the for loop, we will just run that full steps one after another. So first we will calculate this, then we will calculate these two simultaneously, and it will be used for the next step. Like once I plus 1 is calculated, then for I plus 2, that will be act like as a I, like this way it will solve. Make sense? Very good. So that is the Newmark-Beta method. Now here the interesting point is the two things. Means, or maybe the one thing you can say, that is the assumption of the beta and gamma value. That is the something tricky or interesting matter, because in the last case we have seen it was quite straightforward. Like we just have it, assuming it as a linear, assuming it as like constant, or we just do the Newmark-Beta method, then add addition and subtraction, and we ignored some of the higher order terms and we get the solution. But here what happening, we are ignoring, but we are also giving some weights to the existing values. Like for example, if you see here, this term is actually get changed or altered here. So if I put the beta value equal to 1 by 6, which is 1 by factorial 3, suppose if I put beta equal to 1 by 6 or 1 by factorial 3, then what I did, I just ignored the higher order term without changing anything. Am I right? Okay, good. And also if you see gamma is this term, and suppose if I put gamma equal to again 1 by 6, no, sorry, gamma equal to half, sorry, that is not this term, I'm sorry, this is the term which was actually altered here, because that triple dot term, the jerk term, we are altering the jerk term. We are not bothered with the fourth order, means the fourth, fifth, not bothered. So the jerk term we are changing. So here you see, if the gamma value is half, then it is this term and all the other terms are neglected. Agreed? So that means we considered up to jerk. And how the jerk is varied? Jerk is defined as a linear variation of that. So the value of beta equal to 1 by 6 and gamma equal to 1 by 2 should give me the same result as linear acceleration case. Because linear acceleration case means constant jerk, and once the jerk is constant, then higher order term of the jerk all will be 0. Make sense? So once we are making that higher order terms get truncated, absolutely truncated, no effect on that, and we are not altering the jerk term any sort of way, that means we are not considering them and we are just putting them 0, and that is the case of the linear acceleration. Do you guys agree with me? Any doubt, please feel free to ask. Any doubt? Very good. Now, then tell me what will be the constant acceleration or average acceleration? Zero.
Constant acceleration.
Third derivative will be 0. Okay. Any other thought? That is little bit tricky, because if you say, if I just go with, just a minute, yeah, so let me rewrite once more. Xi plus 1 will be equal to xi plus delta t into xi dot plus delta t square by 2 xi double dot plus delta t cube by 3 xi triple dot plus higher. Okay, that was condensed as xi plus delta t xi dot plus delta t square by 2 xi double dot plus beta times delta t cube xi triple dot. And what about this one? Okay, so what we have seen, that these terms fully condensed here with this, and this term is condensed here with this. Okay, that we have seen. Now the point is, linear acceleration we have seen. Linear acceleration means jerk will be 0. Jerk will be 0 or constant? Linear is a constant. So all higher order will be 0. Okay, whatever the higher order are coming, all at 0. So that means these terms actually get 0 in that, and therefore for linear acceleration, beta will be equal to 1 by factorial 3 equal to 1 by 6, and gamma will be equal to half. That is the case for linear acceleration. Now in case of constant acceleration, what is happening? You may say that your jerk is 0, but what is your acceleration in that case? Constant, but it is not same. Let me explain what I want to mean. So if you see, for the average acceleration case, if I think that your acceleration is, acceleration at any value of tau is actually okay, that is the value of the acceleration. it is not that this value. Got that point? Is that clear? No. Okay. If you see in the previous case here, what happening? Your jerk is constant. So you have a constant value of the jerk. Okay. And that value you are substituting. Here, so that value you put and you actually take it out and then find out. But here what happening? Here you are actually trying to calculate this value. And your acceleration is somewhat half of that. Means in the last case, whatever is the value of the jerk, you will actually take it out and then you will somehow remove that from the full calculation, because you will calculate the jerk and you will substitute back and it will be calculated. So if you see, once we do that, then jerk you will again express like this way and you will go ahead. But here jerk is also not present. So in case of linear acceleration, means average acceleration, if I try to write that equation, how can I write it? I try to write it with this. So xi plus 1 should be equal to xi plus delta t xi dot plus delta t square by 2 xi double dot. After that, jerk is 0. So here, if I calculate it, jerk is 0 because this is a constant value. Whatever is the value, this is a constant value. So jerk will be 0. So these and all higher terms all are 0. So this series does not exist after that. Okay. And then what about this one? This also does not exist because jerk is 0. But you need to specify some value of beta into delta cube of this one and gamma into delta cube of this thing. So that actually the problematic thing. And moreover, what happened? From this one you will substitute, because from this step you actually cannot able to calculate anything. Can we really able to calculate anything? Suppose you have just only these two equations. Can we calculate? Because what we need, or maybe we can calculate. Just a minute. Let me check. Okay. So suppose if I start substituting it, I will get C. Look, the problem how it happens. Yeah, there is only one term of the mi plus 1 is remaining, because all other cases, like once you will substitute it, you will just have only this. So if you go like this way, does that method remains implicit or it become explicit? And suppose I have this equation, I just substituted this one here, and if I solve it, I will definitely get this value. But you see, you may get this value, but you cannot able to calculate these two from here because there is no term of xi plus 1 double dot. Because in last case, if you see, you have these xi plus 1 double dot here and here. Therefore, you can able to use 4 and 5, you can able to solve that. Here, suppose if you go ahead, you can able to calculate xi plus 1 double dot, but you cannot able to substitute back xi plus 1 double dot and to calculate xi plus 1 and x dot I plus 1. So this method will not work. Does that make sense? Do you understand where the method get failed? Yes, no issue. Yeah, first of all, do you understood this step? Okay, this step is clear, means linear acceleration case is clear. Any doubt with the linear acceleration case? Like how numeric beta can be converted into linear acceleration? Is there any doubt? No doubt. Okay. Now come to the average acceleration case. Now in average acceleration case, if you see that average acceleration is this much, but you can see if we are considering that due to that average acceleration jerk is becoming 0, then and if we start substituting that similar concept into the original equation of the original numeric beta equation, means this one, like 1 and 2, if we start substituting that jerk equal to 0 in 1 and 2, then what will happen? Then that 1 and 2 equation will become like this. Very simple. Jerk and all other higher order term of will be 0. So everything will get cancelled out. So you will just left with this. Is that clear? Make sense? Anybody has any doubt? Please feel free. Please feel free if you have any doubt. Okay, so all the terms get cancelled. Now what we do? Just go back to the last one. We had the main equation of motion. What is that? Yeah, that is the main equation of motion. So we substituted whatever we got, like xi plus 1, x dot I plus 1, we substituted there. So we have also here xi plus 1, x dot I plus 1, we substituted here. But what we notice? That xi plus 1 and x dot I plus 1 has no term of xi plus 1 double dot. In the last case, if you see, they all have a term of xi plus 1 double dot, like in equation 5, equation 4, you have a term that has xi plus 1 double dot. But here, that xi plus 1 double dot term is missing. So, what is the problem? Once you substitute that full thing, you can able to solve what is the xi plus 1 double dot. But with xi plus 1 double dot, what will you do? You cannot able to calculate the other two states at I plus 1th step. What are the other two states? That is the xi plus 1 and x dot I plus 1. You cannot able to calculate. So, you cannot able to use that xi plus 1 and xi plus 1 for I plus 2 step. So, your solution cannot able to proceed. It will get stopped here. So, there is some problem. Why? Where is the problem? Can anybody identify that? Because already we have seen that average acceleration works properly. Once we did not consider this numeric beta frame, once we just substitute the average acceleration, we see we can able to get it very nicely. If you go back to the class, yeah. So here we can see that very nicely once we are calculating the average acceleration. Yes, xi plus 1 we calculated, and here you see this term was present, and once we calculated, this term was present here. So once we are solving xi plus 1 double dot, we can able to solve xi plus 1 and xi plus 1 double dot, xi plus 1 dot. So that was correct. But now we try to put the same thing in the numeric beta frame. Average constant linear acceleration worked very nicely, but average acceleration blows up. Where is the problem? Where is the problem? Well, we have seen that previous method worked fine. Once we do it previously, it worked fine, not a problem. We can easily able to solve it. Numeric beta also worked fine, not a problem at all. But once we try to incorporate, and previously also we see that once numeric beta, we try to put the constant linear acceleration case, that also works very fine. We can easily able to map all the terms properly. But once we try to put the jerk equal to 0 and try to solve for the constant acceleration, which is also true, in constant acceleration jerk will become 0, but that is not giving the correct result. The full scheme is completely vanished. That is not working. Where we made mistake, or where is the problem? First of all, did you recognize that problem happens? Because once we are talking that some problem happened, first thing we have to understand that did you recognize there is a problem happened, or it is just we are speculating there is a problem. There is actually no problem maybe. Just give some response that whether you got that problem happened or that person is also still unclear.
So I
Yes.
one and xi plus 1 dot compare all xi and xi double dot.
Yeah, this equation you are referring? Please.
Yes.
Yes. Please tell. So just maybe I will just mark it 1, 2, maybe I put it 3, 4, 5, 6, 7. Okay. Now please refer.
4 and 5, if we have xi and xi dot and xi double from E, then we know xi in that equation.
That is also true. Yes.
So then why do we need xi double dot to evaluate those values?
Very good. Very nice point. By the way, did you understood what is his point? Yes. So his point is that we have calculated xi plus 1 dot. Very good. Nice. But we already can also able to calculate this one, because this one we can directly calculate, because we know I plus 1 ith step, we can directly calculate that. All of you agree with that point? Yes, we can definitely calculate that. So therefore, once I do that, I mention, is it remained implicit or it become explicit? Yes, it turned to the explicit scheme. Solution does not blow, but it turned to the explicit scheme. You got that point, na? Because we can able to put that value back. Means we don't need to put that value back, actually. It is already there. So we just can calculate that, but it become explicit scheme. It is no longer remain implicit scheme. Means maybe you can call it some type of explicit scheme. So where you are putting beta equal to 0 and gamma equal to 0. And that turned to the explicit scheme, not implicit scheme anymore. Okay? Because in implicit scheme, because it actually like following some portion of the implicit scheme, but not following the complete thing. Some portion, how I think some portion? Because you are solving at I plus 1 step to calculate for I plus 1 step. But your solution, assumed solution, does not have anything related to I plus 1 step, because you are calculating everything from ith step. Make sense? So therefore, it becomes, when it is not fulfilling all the criteria of the implicit scheme. It's some sort of like a mixed type of solver, where we are not following all the criteria of explicit, not following all the criteria of implicit. Okay. Okay, so where is actually the thing happened? Because that problem happened due to this average acceleration value. We have not considered that average acceleration value this much. Because once it is going, you see that acceleration value remains this. Just cross check. This is equation 4. Just cross check what we got for the linear acceleration case. Look, all the terms are remain same. Just here we have a term xi plus 1 double dot. That term is just missing here. So the value of the acceleration is problem. This scheme what we just made, which is like a in between of the explicit implicit something, so that is somewhere like if you draw that, here you will have xi double dot and here you will have xi plus 1 double dot. So we should solve it from like this, but rather you solve it like this. Got that? Did you understood? And due to that reason, the solver become means a little bit crazy. Okay, fundamentally clear. Okay, good. So So to make the average acceleration from this, what we have to do? So let's see. Just a minute. Yeah, so that is the acceleration. Okay. So how the that one defined? So this defined as x that was the definition of the of that case divided by not 2, that is delta t. Okay, now your average acceleration is this much. So now once you substituted here this value, so this will be actually 0 for the average acceleration, but your top term you need to check how it is actually rearranging. So in that case, what is the thing? You have to use beta equal to 1 by 4 and gamma equal to 1 by 2. So if you do that, let's see, if you put gamma equal to half and beta equal to 1 by 4, then your solution set is actually matching with the average acceleration case. That is some sort of like a forced way to match. If you try to calculate the jar and try to match it, it will not going to match. Okay. So you have to basically see this equation, that this equation how it is coming. So now here if you put beta equal to half, then what happened? This first term, how much is it? Beta equal to half or beta 1 by 4? Yeah, accept. So beta equal to 1 by 4. Suppose if you put here beta equal to 1 by 4, then this term will look like half minus 1 by 4 into, sorry, not beta. Maybe just I will do one thing. I just rewrite that portion. So you can see that once we are solving it, xi plus 1, that is equal to how much? Xi plus delta t into xi dot plus half minus beta into delta t square into xi double dot plus beta into delta t square into now you see, and so this is the term comes from the numeric beta. Okay, and if you see what is for the constant acceleration, the same term is coming. Yes, so that term is coming xi plus xi delta t square by 4 xi double dot. So that comes from the constant acceleration. So you have to match these two things. What is the possibility? That is beta equal to 1 by 4. You see, both the term will match. Your scheme will remain explicit, no problem. Once you are solving xi plus 1, you are using the data of xi plus 1 double dot. Okay. And what happened with this? So this is from the constant acceleration. This is from the average acceleration, AVG acceleration. This is also from AVG acceleration. So now if I also write down this one, delta t into 1 minus gamma and gamma into this. Okay, nice. So that will be xi dot plus delta t into 1 minus gamma into xi double dot plus gamma into delta t into 1 double dot. Make sense? So if I try to match these two terms, your gamma need to be half. So therefore beta 1 by 4 and gamma 1 by 2 converts your equation to the average acceleration method. But if you thought that average acceleration means your jerk is 0, that will not give you the correct solution. Then let's go to the state variable approach. These are the, like up to this what we have studied, these are, yeah, some people still use numeric beta method, although not very suggested, because after the MATLAB and all those things, the ODE solvers and the all class are very nicely defined, so they do not use that numeric beta. But yes, some solver they do. So now let's start looking at how the MATLAB and all those solves. What is the theory behind it? Like once you are solving any ODE in MATLAB, what means, I'm not going into specific algorithms, but I will just try to give you a general idea that how the MATLAB solvers are actually working on the ODE. So let's see that. So the first thing is that we have our equation of motion. So mx double dot plus cx dot plus kx, that is equal to some sort of force. Or you can also write minus mg double dot, whatever, the way you want to write, not a problem. So now you have seen in the last class we did a crazy thing. Do you remember? Yes, x dot equal to x dot. Again we will do the same thing, x dot equal to x dot. And now start considering, because all the previously what we have shown, these are some sort of like a single degree freedom system to us. like your mass is like a mass only. But these solvers, what we are started talking, these can be applicable for multi-degree freedom system. I agree that you have not studied multi-degree freedom system yet, but now start thinking that your M can be a matrix instead of a number, X can be a vector instead of a number only, C also like a vector matrix, X dot vector, again K matrix, X dot vector, and F is a vector, like this way. Okay, that can be also possible to solve, but with the numeric beta and all other classes, that is like for every equation you have to write like this way. That's like a real challenge. Also that, like once we will do the MDOF, we will study that. So like we will do this and then we will slowly go to the MDOF from here only. Okay, so if you see, this is the equation. So now what can I write? I can write it this. So therefore I am writing it M inverse instead of just dividing by M, because it can be a matrix, so I cannot just write divide. Okay, so it's like M inverse Cx dot plus M inverse K into X equal to M inverse F. Okay, so that was my, so that become my new equation. So here I can write X double dot should be equal to minus M inverse C X dot plus minus M inverse K X plus M inverse F, and that favorite equation X dot equal to X dot. Okay, so that is that auxiliary equation. That is, so that is like a equation 1, and that is equation 2, that is auxiliary. Okay, so now, so that helps me to write the full thing in a matrix form. Make sense? So what happened in the left hand side, I will have this equal to make sense? Please check whether it is correct or wrong. Hello, please check. It is all good? Okay. So we get this way. So this can be considered as something like dy dt equal to a times y times b times ft. So if you see how the analogy establishes, you can think that this part is something like your a, y is this full thing, dy dt is this full thing, and this one is b times ft. F of t means, suppose if you see here, means these two forces, means this f and this f are not same basically. This is like a function of time, and some some matrices or some vector, it need to be vector, it cannot be a matrix. So a vector which is varying with time. Okay, that is there. Okay, so now the question comes, how should we solve it? What we are looking for, by the way? We are solving and all those things. What we are looking for? What is our objective to calculate? Of not partial. They are not partial differential. That ordinary differential. This is still ordinary differential equation, but multiple ordinary differential equation, not a single ordinary differential equation. Okay, like previously we are dealing with a single ordinary differential equation. Now we are converted into the multiple ordinary differential equations. So, what is our objective to solve? What we are looking for? Solution of x, or you can say solution of y. In this case, solution of y. Okay, we are trying to find the solution of y, that how y is varying with time. Make sense? So first what we should do, we should pre-multiply with a matrix that is S of t. But S of t cannot be that arbitrary. S of t must have some sort of condition. Now I'm coming into that, what type of condition it should fulfill. So we will get, like, suppose if I multiply with S of t, we will get something like that. Now if I just try to say that what will be the solution of it? ddt of S of t into y. The solution will be ddt of S of t into y plus S of t into dy dt. Can you see this term in your equation? So this is maybe equation 3, equation 4 multiplying with equation 5, equation 6. Can you see any term of came in equation 6 into equation 5? Last term, exactly. That last term is same. So what can I say? That this last term S of t dy dt should be equal to ddt of S of t y minus ddt of S of t into y. Do you understand the difference between these two? One is the ddt on top of S only, and another is ddt on top of S into y. Both. Okay. So what can I do? Let's assume this is 6. So I just substitute 6 into 5. So subs 6 into 5. What can I get? I will get ddt of st comma y minus ddt of st into y should be equal to st into ay plus st into b ft. Now we are telling that, look, you cannot just multiply with S of t, because so it is something like ddt of sty minus, or say this, that is okay. Now that S of t, it was a arbitrary. You see that we just multiply S of t. But now we can say that, look, S of t should be such a way that your this term will vanish. So this term will be equal to 0. So for that thing, what should be S of t? So S of t, the condition should be S dot t y should be equal to minus st ay. Now forget about y. Y is just multiplied with both the side. So if I just forget about y, then I left with this. S dot t should into a should be equal to s minus of s dot t. What type of function can it be? Yes, perfect, great, very nice. E to the power minus at, absolutely correct. How did you say that? Exactly, very good, really nice. So s equal to b into e to the power of minus at. All of you get that how, sorry, what is your name? Anand. Yeah, so how Anand told that s equal to, Anand means that b, small b, but it's okay. How Anand told s equal to e to the power minus at. How did he say that? Suppose you don't know, and in our class we don't have Anand, then how do you know? How do you able to derive that? How do you, that is absolutely the correct answer, no doubt on that. But how will you derive it? Taking logs, yeah. So you can do like this. You can think this is ddt of s of t should be equal to minus s of t into a. So you can write it d of st divided by st should be equal to a into dt with a minus sign. Now take the integral. Okay, that integral will automatically leads to log. Okay, so you will get ln of s of t will be equal to minus at. Okay, so that s of t will be equal to, and with some constant will be there, so that will be like b into minus at. That way we can get that. But fantastic that is directly told. Okay, so that tells we cannot pre-multiply anything. It is arbitrary, although it is not that arbitrary that whatever you find that you put, no, it must follow that condition. So it is some sort of like e to the power function you can multiply only. Okay, and also it is telling that whatever is a is there, because a means this matrix, so it should be e to the power of minus a of that matrix into t, that you can consider as your s. Okay, and that b also we can able to calculate. How? No, we can see that at t equal to 0, what will have? S should be equal to S0. So S should be equal to S0. S0. So that should be your B. So whatever is your S0, that S0 should be act as a B. So that S of t is nothing but S0 e to the power of minus a. That we have to pre-multiply here. So now if I see that, okay, that portion we got. Now we reached here, and so that is equal to 0. So these lead to this form, ddt of s of t into y should be equal to s of t into b into f of t. Make sense? Because that full part is become 0, and that actually leads to these all those things. Okay, anybody having any difficulty, please feel free. I know the course has become too mathematical. Don't worry, I told that at the very beginning that the course will slowly become full mathematical. Like you may be feeling that you will solve only differential equation, because this has to be like that. You can't do anything. Because structural dynamics, mostly all the problems are with differential equation. That is like maybe unfortunate or fortunate, whatever the way you want to take it. It is like that. Okay, so we have that. Okay, now the point is that don't get diverted. What is our solution? What is our objective? To calculate y. Yes. So let's try to find out y. So ddt of s of y, that is equal to this. Okay. Let me just copy it. ddt of s okay. How should I solve? My target is to calculate y. How should I solve it? That is not difficult. That is simple. We can do the integral. Okay. Simply if we integrate, so it will lead to, that will be from 0 to t. So here we can also say that we are doing the integration like b of, and here also it will be 0 to y particular, therefore that will be this into f of tau into d tau 0 to t plus s0 y0. That at s0 it was s0, and at y equal to, and at y t equal to 0 it will be y0. So that portion will be going that side. So we will live with that, left with this. And we also know that s of t is equal to s0 e to the power of minus at. So what can we write? A is equal to s0 inverse e to the power t s0 inverse e to the power of minus a tau b f tau d tau plus s0 y0. Do you get that? Simple thing. This is this. Once this is coming here, this is become s0 inverse, because that will be dividing into a to the power t. I cannot directly divide because it can be a matrix also. So that's why I put inverse instead of divide. But e to the power at is like a constant term. So that is e to the power of minus at will be e to the power at. Okay, got that? So we can see that by this way actually it can be possible to solve. So here, like if we are thinking that at ith step we are solving, then I plus 1th step we are solving. So these all matrices should be calculated for ith step. Then that thing can be go for I plus 1 step, I plus 2 step, I plus 3 step, like this way it can. And these are like a quite solid methods. And these can handle the multiple degree of freedom very nicely. Whereas like doing the simulation using the numeric beta for multiple degree of freedom is like a big challenge. That is a big challenge, literally. Because they are primarily defined from the single SDOF systems. But these are the solvers for the MDOF system where you are just dealing with the mass matrices. Although I know I have not introduced those things, but still just take it as like a, instead of a mass, you are having a matrix. Just that way.